Please go ahead.
Okay, sir. So, regarding the voltage, the height of the squares. So, this height of the square, one small square is concerned with 0.1 millivolt and one large square. So, one large square consists of 5 small squares. So, this 5 small squares or one large square, it is concerned with 0.5 millivolt. 0.5 milliwatt. I hope you understand. Time for 25 small squares or 5 large squares, it is 1 second. So for one small square, it is one large square, it is 0.2 second, and for one small square is 0.04 second. Regarding the height, for one small square, it is 0.1 milliwatt, and for one large square, it is 0.5 milliwatt. And there is something known as standardization of ECG. Standardization of ECG. So while taking the ECG or while reading the ECG, we'll be seeing before each wave, before the first waves, that is AVR, AVL, and AVR, we'll be seeing a wave like this. So this is the standardization of ECG. So the well standardized ECG machine, the height of this wave will be 0.5 plus 0. One large square is 0.5. So 2 large square is 1 milliwatt. The height is 1 milliwatt. The height should be 1 milliwatt. So what we are talking about the P wave or what we are reading in our book, it is regarding the standardized ECG. That is, the height should be the milliwatt. It should be the standardization should be 1 milliwatt. 1 milliwatt. If the standardization is less, if it is half standard, it will be represented like this. If it is standardized, fully standardized ECG machine, the representation will be like that. It is 2 large squares. So it is very, very essential to see the standardization of ECG before reading an ECG. Because if it is half standardized, the height of the QRS changes, the height of the P changes, the height of T changes. So what happens? We'll be seeing that the height of the P is less. We'll be saying that the height of the QRS is less. So what happens? The interpretation will differ. So it is very important to see the standardization of ECG before reading the ECG. So what we are reading in our textbook is about a standardized 12-lead ECG. The standardization should be 1 milliwatt. I hope you understand about this. So next, regarding the waves of ECG. So by this slide, we'll be completing today's session. This is regarding the basics of ECG, and this is the last slide, and this is also very, very important. So I took only the important points as far as ECG reading is concerned. So there are so many waves in ECG. There are positive deflections, there are negative deflections, etc. So the most important waves are P wave. The first wave is P wave. Second is a negative. P wave is a positive deflection. Next wave is a negative deflection, which is the Q wave. Next is a positive deflection, R wave. Next is a negative deflection, S wave. And next is a positive deflection, T wave. So these are the important waves in ECG, and in some ECG there will be presence of another wave after T wave known as U wave also. But in normal ECG, it is very difficult to find out U wave, and it has less significance. And if it is present, it is very, very important. And U wave is not getting much importance as that of other waves in ECG. So P wave is known as atrial. P wave is the only wave in the ECG which is concerned with the atrium. Very, very important. P wave is the only wave in the ECG which is concerned with the atrium, and rest of the other waves, it is concerned with the ventricles. So P wave, it is the positive deflection, and it represents atrial depolarization. We know about depolarization, that is contraction. Depolarization is contraction. So it is concerned with the depolarization, that is contraction of the atria, or it is the only way which is concerned with the atria, the ECG. Next, so QR and S, we'll be calling this as QRS complex, because it represents ventricular depolarization. Ventricular ventricular depolarization. So ventricle is a big thing as far as the atria is concerned. The power of the ventricle is more. When compared with the right ventricle, the power of left ventricle is more. We all know that the musculature of left ventricle is more than that of right. The musculature of right is about 2 to 3 millimeter. We all know that. And the left is about 10 millimeter, because this left ventricle has to pump the blood to a whole part of the body through the aorta. So the papillary muscles, the caudate tendinae, the valves, everything is very strong when compared to the right ventricle. And also when compared to the atria, ventricle is very, very strong. So this depolarization of the ventricle, it is represented not by a single wave, it is represented by a complex known as QRS complex. QRS complex. Next is T wave, and this T wave, it represents ventricular repolarization. Ventricular repolarization. So P wave, the positive wave, it represents atrial depolarization, atrial contraction, and this is the only wave in the ECG complex which represents the atria. Apo, when there is any defect in the P wave, so we can say that there is some problem with the atria. So over, after P wave, when there is any problem, it is not concerned with the atria. So P wave, it represents atria. QRS complex, it represents the ventricular depolarization. Since the musculature of the ventricle is more, there will be more events, and there is interventricular septum and all. There will be more events taking place during ventricular depolarization, and it is represented by a complex in the ECG known as QRS complex. And T wave, it is a single wave, it is a positive wave. It represents the ventricular repolarization, that is relaxation of the ventricles. So you remember that cardiac cycle. So it represents the relaxation of the ventricle. I told ventricular relaxation, it takes less time, and ventricular depolarization, it takes more time in the cardiac cycle. So it is represented by a complex, and ventricular repolarization takes less time. It is represented by a wave. I hope there is no doubt. And the importance is, now we are going to connect the conductive system of the heart with the waves of the ECG. Okay. So we all know that the conduction system of the heart, it is SA node. It is the pacemaker, natural pacemaker of the body. So once the SA node contracts, what happens? There will be production of impulse in the SA node, and this impulse will be traveling towards the internodal pathways to the AV node. Yeah. So to the AV node. So when the SA node contracts, this atria starts contracting, and there will be production of P waves. Once the P wave ends, this electrical impulse will be reaching the AV node. It will be reaching the AV node. So P represents atrial depolarization. So once the SA node contracts, the P wave starts, and when it reaches through the internodal fibers towards the AV node, the P wave ends. And from the AV node through the bundle of his to the bundle branches, the electrical impulses will be traveling. So at that time, so there is a time gap from the AV node to the ventricles, to the bundle branch, to the right and left bundle branch. So there is a gap before QRS, that is ventricular depolarization, and it is represented by a segment. It is represented by a segment here. Understand? It is represented by a segment here. So P wave represents atrial depolarization, and before Q wave, we will be talking about the segments later. So this segment is, we will be talking about the name of the segments and all later. So this segment, it represents the travel of the electrical impulses from the AV node till it reaches the ventricle. That is, till it reaches the bundle branch. That is through the bundle of it. So till it reaches the bundle branch. Then once this impulse reaches the ventricles, what happens? This ventricle starts contracting from the bundle branch. It reaches the Purkinje fiber, and there will be spread of electrical conductivity to all the musculature of the ventricles, and ventricle starts contracting, and there will be production of QRS complex. And what happens once the ventricle contracts? This blood will be pushed to the aorta and the pulmonary artery, aorta and the pulmonary artery. So what happens when the blood is pushed upwards, the pressure in the ventricle is reduced and the ventricle goes for relaxation. And when the ventricle relaxes, T wave will be produced. T wave will be produced. So now we can correlate this conductive system of the heart with the ECG. So when there is any change in QRS complex, there is something problem with the ventricular contraction. When there is any change in the T wave, there is some problem with the ventricular relaxation. When there is any change in the P wave, there is some problem with the atria. And when there is any change or change in length of these segments, which is in between length of segments, what happens? There is some problem between the atria and the ventricle. So this is the interpretation. So the most important thing is we said about atrial depolarization, P wave, but we are not. There is nothing to represent atrial repolarization. So there is atrial repolarization or atrial relaxation taking place, but this atrial musculature is very small. Before this atrial repolarization, what happens? This ventricular musculature is very large and it is very strong and it depolarizes. So what happens? This atrial repolarization get merged with the ventricular depolarization. We cannot get the atrial muscles will not get time to produce a wave since the ventricle contracts suddenly or the musculature of the ventricle is more and this ventricles contracts very strongly so that the atrial repolarization get merged within the QRS complex. You understand? So we are not getting a wave for atrial repolarization. So these are the waves in ECG. So we will today we have seen about the surface marking of the heart, borders of the heart, surfaces of the heart, cardiac cycle. So here ventricular systole takes very little time when compared to the ventricular diastole. So ventricular diastole is a large process. So it produces a complex in the ECG wave. Ventricular systole is a small process. So it produces a wave in the ECG complex. Then conduction system of the heart. This Bachmann's bundle. Don't forget about the Bachmann's bundle. Then this is regarding depolarization and repolarization. Difference between electrodes and leads. Electrode. We are seeing the leads. We are not seeing the electrode. What we are seeing in the machine is the electrode and what we are seeing in the graphical representation is the lead. So there are 10 electrodes and 12 leads. And this is about lead 1, 2 and 3. The rule is, the first rule is above downwards or below upwards, the positive pole will be in the lower side. And second rule is when from right to left or left to right, the positive pole will be in the left side. Please remember this because when there is positive pole, in the next slide we'll be seeing, when there is positive pole, the place where the positive pole exists, it will be seeing that particular surface of the heart. So this is very, very important. Lead 2, 3 and AVF, it will be seeing the inferior surface of the heart. Lead AVL and lead 1, it will be seeing the left lateral surface. AVR, it will be seeing the cavity of the left atrium. V1 and V2, it represents the right ventricle. V3 and V4, it represents the septum. V5 and V6, it represents the anterior and lateral wall of the left ventricle. This is regarding the ECG paper. ECG paper travels at a speed of 25 millimeter per second. So for one large square, it is 0.2 second and one small square, it is 0.04 second. Regarding the height, 1 millimeter corresponds to 0.1 millivolt and one large square corresponds to 0.5 millivolt. And regarding the standardization, in standardized ECG, it is represented by, the standardization is represented by 2 large squares. What we are talking about is a standardized ECG, and it is very important to see the standardization of the ECG before reading the ECG waves, before reading the leads or before interpreting, because when there is less standardization or half standardization, the height and the breadth of the complexes and waves will change. And this is regarding the waves of the ECG. P wave, it represents the atrial depolarization. QRS represents the ventricular depolarization. T wave represents the ventricular repolarization. As the atria is small when compared to the ventricles, this atrial repolarization is not represented in the ECG. So this is regarding the basics of the ECG. In the next class, we will time we will see about the axis, cardiac axis, which is very, very important. Cardiac, once we understand the cardiac axis, it is like we are understand the ECG. 90% ECG was completed once the cardiac axis is understood. So, sir.
Yeah, now open for questions. If anybody wants to clarify something, you can ask the questions. Up to this part is the basics of ECG. And when we go to the actual ECG reading and other things, so these are the basic things which required to keep in your mind. So if anyone interested to ask some questions, you can ask. Please unmute and ask questions. I think everybody got the point.
Hello, good evening, Krishneswari. Dr.
Good
Krishneswari.
evening, sir. Good evening, sir.
It was a wonderful class.
Thank you, sir.
To 90%, I could get it, whatever you have explained. It was
Okay.
properly explained, and
Okay,
it was
sir.
quite clear. Only thing is that I need to sit and study further over it, because we hardly get some ECG reports during our practice.
Okay.
So
Okay.
when we get also, the patient himself explains some of the things, so we get some knowledge from them itself. So now I think of the next classes when it comes up, I think we will be getting further deep into it. And
Yes,
when
sir.
we go through when you bring in the next class few ECG samples, like a few different type of ECG records, when you come bring it up, I think we will be getting more deep into it, and we can
Yes,
ask
sir.
further questions
Okay, sir.
based
Sure,
on that.
sure. Sure,
Thank
sir.
you, and thank you for taking so much pain for giving us this deep knowledge into ECG reports and all. Thank you. God bless
Thank
you.
you so much.
Thank you very
Thank
much.
you, sir. Thank you so much.
So any comments from others, please? Then I think time to wind up. If anybody is interested to comment on this, you can have it. No issue. Please go ahead. Then only
Should I make any change, sir? Should I make any change during next presentation or what?
That others has to say. I don't have any comment on this. So I think
Sir, unmuted.
so we can wind up this session for today's session, and the next session will be declaring on after your convenience. And Dr. Krishneswari, thank you for your
Thank you so much, sir,
sincere
for giving
effort.
the opportunity. Thank you so
It
much,
is
sir, for
not
giving the opportunity.
it is not that opportunity because you are already engaged with a lot of work, and in between you are coming over here without. I told you will not be giving any remuneration for
Pictures and
this.
all.
So anyway, without any remuneration, you have spent a lot of time with us for giving a valuable topic. So you can go ahead with the next session also, whatever as
Okay.
usual, your style of presentation and style of working. No issue.
Okay,
And
sir. Okay.
now, thank you so much for on behalf of this.
Sir,
We are all
unmute,
we are,
unmute.
we are all what do you call this? Is only a friendship group actually. So we do some webinar
Happy
at
to be a
night.
part of it, sir.
Yeah. So many of these doctors are all busy practitioners in this group. Few are
Sir.
from other colleges also working,
Okay.
and as a professors
Okay.
or associate professors, they are working there in other colleges. Some are all very busy practitioners. Some are from outside India.
Oh.
They are all staying there only, and most of the people are having some practice, and that's why they a little bit late.
Oh,
Okay,
no,
so
it's okay.
it is a small group. It is not a very big group actually. Okay? So we are interested to update our knowledge. That is the idea big. So thank you so much for your valuable time to spend with us for this very good presentation. So now you can leave, and we are all
Okay, sir.
having a lot of appreciation for you. Thank you so much.
Oh, thank you so much, sir. Thank you so much. Thank you all.
Thank you, doctor. Thank you.
Thank you. Thank you, sir.
Hello, Murli, any group discussion?
Now, if anybody wants to suggest something, they can. 1 minute. Please follow.